on production and costs. And actually, we have finished on the part of cost, and then we will move on to, we have finished the part on production, and we will move on to costs. Okay, again, the objective is to maximize profit, okay? And so because of this, so we know that we're going to use calculus, okay? So for a function, fx, okay? If you want to get to the way to find a maximum, so you have to find f prime x, okay? F prime x must be equal to 0. And what is this? So let us say this is the unit of input, and this is the production, Q, okay? So here is TP, okay? So what is TP? Total product, okay? And so fx, okay, this is also fx. And if we are going to find a maximum, so first of all, we have to find the first degree derivative. And the first degree derivative tells you that this is actually, okay, this is actually the variation, okay, of fx, the changes rate, okay, the rate of changes. And so here, this is the fx, total product, and the slope, okay, the slope of TP, that is the slope of fx. This is the rate of changes. And so when the rate of changes, when it gets to this part, okay, it is equal to 0 because it's already at the top, okay, at the peak. So at this point, we get a maximum. But be careful, because when you move up like that or move down like that, you both get the rate of change is equal to 0. The slope is equal to 0. And so if you want to make sure that what you get is a maximum, you have to make sure that you have the second degree condition. So double prime has to be less than 0. Okay? Because from there, you know that rate of changes goes down. It means that it's going down here, right? If it is here, then the rate of changes moves up. It is moving up here, right? So it is at a minimum, okay? So as a matter of fact, if you want to make sure that what you get is maximum, there are two conditions. The first one, f prime has to be equal to 0. The second, f double prime has to be less than 0. So later on, we're going to show you that for a firm to maximize profit, you have to make sure these two conditions are all met, okay? And then production has long run and short run, okay? The difference, okay? 李云晓, what's the difference between short run production and long run production? So in the long run, all variables are variable, okay? All costs are variable, okay? But in the short run, there has to be something fixed, okay? Okay, let's move on. We already finished this part, so we're gonna go over a little bit quickly. And then we have talked about economies of scale and returns to scale. These two concepts are related, but they are different, okay? First, return to scale. Okay, for return to scale, you have to use all the variables, all the inputs in equal proportion. So it means F, L, K is equal to Q, right? Then you have to have use L and K in the same proportion. So T, L, T, K, and for this to compare with T times Q, okay? This is called return to scale, and we have three. Greater than, equal to, less than, it is increasing, okay? Increasing return to scale. constant returns to scale, and the last one is decreasing returns to scale. And the other one is economies of scale. Economies of scale. What is that? It means production level goes up. Okay, LAC goes down. What's LAC? Long-term average cost. Okay, long-term average cost. And so there's economies of scale. There are also diseconomies of scale. Okay, if it is diseconomies of scale, it means that production level goes up, LAC goes up. Okay. Okay, let's move on. So profit maximization and short run, long run. Okay, this is the application in book. Please read that on your own. And capital goods, basically we say it is capital, right? It's machine, equipment, all these things. But in terms of investment, when we talk about investment or the stock market, capital means money. But here, capital means something that you can produce other goods. Okay, and production function is at the top. Here you have Q equal to F of x1, x2, x3 to xn. It means that you can have a lot of inputs. Okay, whatever you're going to use. But to simplify the analysis, usually we only have two. Okay, and we mentioned this. I'm not sure, but in the test, if we have some question like this, you will be required to derive marginal product, okay, average product, okay. So average product, marginal product, okay. So NP is here, right? DQ, DL, okay. So the changes in production level due to the changes in input, and here we use labor as the input. And MPA basically this means a different kind of input, okay? And if it is AP, right, AP it is Q over L, okay, Q over L. And then we have the laws of diminishing marginal returns. Just like when we talk about consumer, we have diminishing marginal utility, okay? And then we talk about production, then we have Isoquant and marginal rate of technical substitution. So here, basically that's about the same as the analysis of consumer behaviors. So for consumer, okay, you have indifference curve, very similar to Isoquant. And the slope of indifference curve is marginal rate of substitution, okay, so MRS. And here, for the producer, is MRTS. And then, for the factors of production that we use, or the input, it could be perfect substitute or perfect supplement. That is the same thing as what we have done for the analysis of consumers. Okay, so here the straight line here, okay, it is actually an Isoquant. And here it is the way it looks is because it is perfect substitute. Okay, and then here you have perfect complements. So it's like a rectangle. Okay, so again we get to return to scale, constant return to scale, increasing, decreasing. And we have discussed this several times. Constant return to scale is the most sensible way to produce. Okay? Let's move on. And so this is exactly the production curve that I have drawn on the blackboard. Okay? And this is at different levels of production. Okay, different levels of production, and you can get to. And in the homework, okay, you have some question like this. You are required to draw diagrams like this. Okay, costs. Costs is a little bit more complicated. Okay. So let's start from the short run cost first. So we have total cost equal to total fixed cost plus total variable cost. Okay, because it's a short run, so we have something like this, and you can treat it, as a rent of a shop or the equipment of a shop. Okay, so basically, just like you want to run a breakfast shop, you have a stove, an oven, okay, a refrigerator. All these things could be considered as fixed or the rent of the shop, and the variable would be labor. Okay, all the ingredients you put into whatever sandwiches that you or hamburgers that you produce for the consumers. And now we're gonna talk about the average. Okay, so TC divided by Q is equal to TFC divided by Q plus TVC divided by Q. So here you have ATC is equal to AFC plus AVC. Okay? Questions? And then we talk about marginal cost. So marginal cost is equal to changes in total cost due to changes in output. And average cost is total cost divided by output. And from here, also this is in the homework. We are trying to figure out what's the relationship between marginal cost and average cost. Okay? So first, we are going to talk about the relationship between marginal cost and MP, marginal product, and average cost with average product. And now let us assume we only have one input, and that is labor. Okay? Okay. And so this part is gone. So MC is equal to DTC DQ. Okay? And because we say, in this kind of production, there's only one input, so that's labor. Okay? So what is the total cost of labor? DW times L. Okay? So total cost, right? And labor is the only input. And the cost of labor is W. So W times L. This is the total cost. And DQ. Okay? Any question to this point? Okay, so what's going on here? Because W is a constant. Okay? W is a constant, we can factor that out. So you have W times DL DQ. Okay? Any questions? And what will happen is that it is equal to W 1 over DQ DL. Okay? So this one, make sure that you know that this one is the same as this one. Okay, so what you get? What's DQ over DL? Wang Ziqi. Here? No. Yu Huayuan. Not here. Chen Xizai. Yu Huayuan. Okay. What is this? I beg your pardon? What is this? Gao Jiayan. Gao Jiayan. What is this? DQ over DL. Hong Kaixuan. DQ over DL. What is this? Xie Xinyou. What is this? DQ over DL. Marginal product. Exactly, right? Changes in production, okay, due to changes in input, right? changes in production due to changes in input. So this is MP, right? So what does that mean? MC and MP are reversely related, okay? MP goes up, MC goes down. MC goes down, MP goes up, okay? Questions? Then we're going to talk about what is the relationship between AC and AP, okay? Questions? Okay, so AC is equal to W times L divided by Q, right? Because we say labor is the only input, okay? Labor is the only input. And total cost, the amount of labor, and the cost, the price of labor, so this is what you get, total cost, okay? And the same thing, so we're going to have W times 1 over Q divided by L. So this one is actually equal to that one, okay? 叶一方. So what is this? Q over L, what is this? Excuse me? TP, are you sure? TP is Q, right? Total production. MP, marginal. There's no differentiation here. So, 郑一林, what is this? AP, right? This is the total production divided by L. So that's per unit of labor output, okay? Output of per unit of labor. So it will be W over AP. So that is the same thing here, right? AC and AP are reversely related, okay? AC and AP are reversely related. AC goes up, AP goes down. AP goes up, AC goes down, okay? Okay. So here, the book also talks about a little bit some basic concept, accounting costs, economic costs. Actually, in our class, we only focus on economic cost. And rental rate, forget about it. And sunk cost is that. So for example, you spend money to acquire a machine. Okay, suppose you spend money to acquire a machine. And later on, because of changes in conditions or any other environment, so you cannot use it. That is we call sunk cost. Okay? What we care about is opportunity cost. So some people, pay for something and don't use it, it's useless. So, sometimes we say crying over spilled water or spilled milk. It's gone, it's gone. So when you have a machine, you talk about your machine, okay, the opportunity cost of your machine. And whatever you have already paid, the money is gone. Okay, so you have short run total cost here, okay? So this is the production function, okay? And short run production function, here, you notice that you have K bar here, right? K bar. One on top, that's called bar, okay? K bar. It means that, the capital is fixed. So that's about short run production, okay? So here you have short run total cost. So that is the same thing here, right? And you have VC, but I put it as TVC. And FC, fixed cost, I put it as TFC. So that's basically the same thing. So you have short run variable cost and short run fixed cost. Okay? And this is short run marginal cost. So that's the same thing as what I put up there. DQ, okay, over the, the marginal cost. So it's DTC over DQ, okay? So you have several concepts here, so total fixed cost, right? TFC, total variable cost, TVC, and short run total cost, when we talk about short run, and then you have average fixed cost, average variable cost, and here you have short run average cost. Okay? So when you look at a table like this, I'm not sure whether I'm going to have such questions in the midterm, but you definitely have to be able to do this. Okay? So let us check. So here, variable cost, right? So all the way down is the same, right? All the way down is the same. And then here is the variable cost, okay? So when the production level is 0, you got 0, okay? So because you don't have any production. And when the output is equal to 1, the variable cost is 30. When the output is 2, the variable cost is 49. And so I want to point out this. To know how much variable cost is, you only need, to know the marginal cost, you only need variable cost because fixed cost never changes, okay? So here, we are going to derive marginal cost. So when production level is 1, variable cost is 30, and when it's 0, it's 0, right? So marginal cost is equal to 30. 30 minus 0, so you get 30. And then when output is equal to 2, variable cost is 49. So what you get? Because 1 unit, the variable cost is 30, and 2 units, the variable cost is 49. So the additional cost is 19. 49 minus 19. So the number on this column, okay, the number on this column is derived by this one, okay, this row, okay, 49 minus 30, and here is 65 minus 49, and etc. Okay? And average fixed cost, it is the fixed cost divided by output. Okay, so 50 divided by 1 equal 50. And 50 divided by 2, you get 25, right? 50 divided by 3, you get 16.69, and etc. Okay? And average fixed variable cost is this number here, this column here, divided by 1, 2, 3, 4, all the corresponding production level. Okay? So you have to be able to complete a table like this, and there is one homework in the textbook. Okay, so help you to understand what's going on here. Okay, and so now this is what you get. You have short-run marginal cost, short-run average cost, and and average variable cost, and here you have average fixed cost. And so there is one thing that you may notice. Okay, the gap. Okay, the gap here and here. Okay, is smaller, smaller, and smaller. So why the short-run average cost and the average variable cost, the gap shrinks? 金圣岛那 here. 卢佑祥. Okay, why the gap here becomes smaller and smaller? Yeah, so this is short-run average cost. So that's in my diagram say SATC, right? Average total cost, and here's average variable cost. So these two curve, the gaps shrinks as production level goes up. Why? Here, right? So why the gap shrinks as production level goes up? Wang Xiaohui. Why the gap shrinks as production level goes up? there's a gap, right? The distance between the two, the gap, okay? The distance between the two. Why the distance between the two curves shrinks as production level shrinks means become smaller, okay? Why the distance between the two curves becomes smaller as production level goes up? Excuse me? Louder. The fixed cost never changes, right? The fixed cost never changes. You can check here, right? What is AFC? TFC divided by Q, right? And so here is ATC. So ATC minus AVC is equal to AFC, right? So the distance between ATC and AVC is AFC. And it is here. As production level goes up, because total fixed cost is fixed, and Q goes up, what about the whole thing? Q goes up, the whole thing goes down. So because of that, the gap, the distance shrinks. Okay? Okay, let's go on. And it marks 2 points. Okay, it marks 2 points. One is B, okay, one is A, okay? So here is where MC equals A. I prefer to use ATC, okay? Okay? This is at point B, and then at point A. At point A, okay, you have MC is equal to AVC. These 2 points are very important. Okay, when we get to analyze the perfect competitive market, it is very important. Okay, later on we're going to show you. Okay, let's move on. And actually, last semester we have dealt with this. Okay, production. Okay, Q is equal to a production function FLK, and A is equals to A times AL to A's power and K to B's power. Okay. And it shows, the production function may look like that. Okay. And here you get, here is 400, right? Here is 200. What does that mean? That means you get more capital. Okay, you get more capital. We want to skip this. Okay, we don't want to talk about the fixed cost, variable cost of a mine. Okay, so you're going to read this on your own. And here you have an ISO cost. Okay, ISO cost is the same thing as when we talk about consumer. Okay, the budget line. Okay, so the analysis is when we talk about consumer, it is X1, or X, Y, and you have budget line, right? And then you have indifference curve. Okay? When we talk about producer, that is almost the same thing. Only that X is no longer a good for consumer. It is a production input for producer, L, and here it is called K. And this is called budget line for the consumer, but for producer it is called ISO cost. And what it is, it's called Isoquant. So if you remember, some of you, also took microeconomics 1, so you know that we have an equilibrium at this point. So at this point, the budget line, the slope of the Isocost will be equal to the slope of Isoquant. So what would be that? That would be, okay, R, W over R, okay, and here you will be MPL over MPK. So what does that mean? That means these two has to be equal to each other. So what you get is MPL divided by, W is equal to MPK divided by R. And what is that? That is MP for dollar. It means that for each dollar you spend on L and each dollar you spend on K, what you get the same kind of marginal product. So that's the marginal product of your money, okay? And that's basically the same thing as when we talk about consumers. So consumers, what we have? We have MUX divided by PX is equal to MUY divided by PY, and you get MU dollar sign, right? So that's each dollar you spend, whether it's on goods X or on goods Y, you get the same kind of marginal utility. And for producer, it is for each dollar you spend, you get the same marginal product, okay? So here is how you get the equilibrium, okay? Here. And remember that. So when the money you spend, so suppose the situation is like this. So in this case, what should the firm do? The producer should spend more on labor, because for each dollar you spend on labor, the marginal product is much better than the marginal product of capital. So in this case, you should, and also this is in the test of last year, okay, the final exam. So only when these two are equal, okay, only when these two are equal, that you get the efficient solution there, okay, at optimal production. And here we have another one we call output expansion path, okay, output expansion path. What is this? Okay, because the price of inputs may change, okay, the price of input may change. For example, now we know that the gasoline, okay, oil, is getting much more expensive, right? So because of that, the cost of capital may increase. So somehow the price of labor has not changed much. So what should the firm do? The firm may switch to more labor, okay, more labor. And later on, when the oil prices goes down, it may be more efficient, okay, to use capital. So it depends on how you're going to move. So in this case, here for this section, it moves a little bit toward capital, right? So there will be capital intensive changes, okay? Capital intensive. And here, it moves a little bit toward labor, right? Then it's called labor intensive. And somehow if the changes may be more drastic, so something like this, it will be totally labor intensive. And if it moves like that, it will be totally capital intensive, okay? And as you can tell, for so many years, we have used much more much more capital than before, like use robots, right? So if you want to produce cars, actually you don't use that many people now, but you use robot, okay? So, Ye Yifang, what is robot? Exactly, okay. And now we get to the relation between short run and long run costs. Actually, there's a series of adjustment. Okay, so here it is a fixed condition, right? So the labor is the capital is fixed, and this is the output expansion path. So it really depends on how the price of labor changes and how the price of capital changes, and the company's gonna find an optimal solution for the use of the production. And so, this is an example. So you have here at this point A, E, and C, and so perhaps at this point is the best, but then as the economy changes and the technology changes, the firm will try to find out what is optimal for it. This is called envelope curve. Okay, envelope. Envelope means, it is a little bit difficult to explain it, but let me show you. Here, okay, the orange line. Okay, the orange line is what we call long-run average cost. Okay, long-run average cost. And for the long-run changes, actually, you have to trace through the short-run, we call locus. Okay, all the points. Okay, locus means all the points. So this is the optimal solution for a short-run solution. Okay, optimal production for a short-run solution. And then, as the production level goes up from Q1 to Q2, Q3, Q4, right? Each different stages, you have each different short-run production. And then for each short-run production, you have short-run average cost. And so for all these curves, okay, if you trace them all together, then you can see the long-run average cost curve. Okay, so here is how to get it. So, for example, for production level Q1, okay, for production level Q1, you're gonna use SRAC1 here. Okay, if it is something in between, okay, then you want to use the long-run average cost curve. Okay, so as a matter of fact, how do you get the long-run average cost curve? Actually, is as a firm expands. Okay, when a firm expands, and at each different stages, the firm use different level of capital. Okay, and so trace all the points together, you get the long-run average cost curve. Okay, let's take a break.